This is the Architectural Review Roundtable, talking about Adelaide Wharf, the housing scheme in Hackney, East London. And we're talking now about structure and construction with Hanif Kara of Adams Kara Taylor. Hanif, the striking thing about this project, the most striking thing, are the balconies. Now, this is a piece of structural ingenuity. Tell us how it works.
It's actually very simple. It's suspended from the top. So all the balconies hang from the top. What's made it much easier is that the usual problem for balconies is that they create cold bridges across because they're connected to the primary structure. So in this particular case, I think what's helped us enormously is what the others have alluded to, which was the research that had gone on earlier and having a lot of collaborative discussions with contractors earlier. So the way the project was set up, I think the simplicity not only of the architecture and engineering, the fact that the early work in the way the land is bought and the whole deal was done, plus the designers on the table and then setting up the contractor on the table at the same time, really allowed us to break through some of the rules of what shouldn't be done. So the cold bridges are really don't exist in this one because the balconies, as well as being suspended, are only really restrained by the facade, which is something that's unusual. Now, normally, that's not doable because we don't have joined up thinking from the front to the back end of construction. In this situation, we had all the relevant parties on the table. So what thinking that the architect was trying to bring into the work could easily be dealt with by the group that was around the table.
And how long did it take to get to this solution? Was it you knew you could do it? It was only a question of how, or was it something? Well, we're not sure if we can do this.
No, I think a lot of these things, certainly from the more intellectual end of designers, are doable. The problems usually are to do with planning, politics, or a construction issue, and I think that's what was eroded very quickly on this particular project. So we've always felt that this is doable because they do it in other parts of the country or other parts of the world, let's say. The system here doesn't allow it because the rules are different. But when you have the contractors on the table and we can persuade people how to, this is what we can design and make it work on paper, how would you make it? So in this particular instance, the Czech fabricators who made the facade were quite like the rest of us into the scheme. So when we persuaded them that their skin could actually support the balcony, which is usually a high-risk item for most British contractors, it was actually doable.
And at what stage did the conversations take place with fabricators, contractors about the entire facade and then how it would relate to the structure carrying the balconies?
At the very early stages. I mean, that's what is I think probably the singly most successful thing about the whole project is the whole collaborative thing. Because what often happens is that we all work in silos, and often we do our bit and then there's no joined up thinking in terms of the contractor. We go out to tender and the rest of it. So the process is kind of not seamless. In this case, as soon as the AHM team had the idea of trying to do this, we were able to say, well, it's easy to do, but we can't guarantee how we make it then. But because the contractor's on board, you were able to have the discussion generally. And all the normal risks and fears that people have disappear because you're all on the table at the same time, which I think comes from, it's the credit in the way this project was not only procured, but also in order to get the quality of the project, it had to be done in a certain speed because a lot of money comes from time. The longer you take to make these things, the more it costs. So one of the additional benefits or pressures of setting it up like this was that we all knew we had to achieve it in a compressed time with speed, which means that you generally collaborate better.
Can I just add one thing? There was an idea about time in the facade. There's a lot of client expertise talking about the benefits of unitised cladding and how that's offset by the problem of getting that cladding around a balcony, which meant actually we could clad the whole building and then clip the balconies on afterwards. So it's kind of quite a nice bit of, everyone was bothered to solve the balcony problem because the benefits of the time and the unitising were worth winning. So it's kind of quite a nice example of that combined thinking on all sides.
Hanif, if you work internationally, I'm struck with this project by how international the collaboration was in respect of contracting, fabrication, and so on and so forth. I mean, is it true to say that these days, I mean, almost every project becomes international?
I think there's no question about that. More and more we can borrow and learn from each other all the time in this situation now. The world is a much smaller place, as we discovered through this.
And were there other examples from the work that you did of this question of time saving? I mean, this was a pretty fast contract once all the prelims were out of the way. I mean, once the building started coming out of the ground, it was fast.
Yeah, I think for at least for AHMM and AKT, it started a while ago. We did do a very low-cost scheme for in Birmingham for the Joseph Rowntree Foundation, which was delivered very quickly. The difference this time was, as I say, in that particular scheme, we still had to procure it in a traditional way. So not all the parties were on the table, where here I think Elliott had brought together the whole process into the design process as well, into one. And therefore you could do it all much quicker. I think that was one of the reasons why we could improve and therefore get the quality out of it, I think.
Can you just explain, just because not everybody understands this or they don't understand it fully, just exactly what is a unitised facade?
Over to Simon.
I mean, there's a client idea. It means that you bring on the back of a lorry an entire, 5 metres by 3 metre single floor-to-floor panel, which you can also finish on the inside. So you're literally bringing a whole piece of architecture and placing it, and then placing its fellow panel next to it. It's like a vast brick. And it means that was made in Czechoslovakia, that's brought on a lorry, that's pre-finished. And one of the key ambitions we worked with Elliott and his team on aesthetically was how that doesn't then create a sort of factory look to the building, how you can use that system at the same time express wholeness rather than a series of components.
I think it's probably the easiest way to think of it is that the wall of the flats and the balcony work as one big brick. What you see today in a lot of construction is those things are assembled separately. They need different types of scaffolding and lots of labour, whereas this was kind of as one large brick assembled, and that can only happen when the balcony and the facade is made by the same person, which comes from a design process, because if you attach it to the structure, you'd have to build it before the facade often.
So this takes the logic of prefabrication to a constructional conclusion, as opposed to the delivery of lots of prefabricated bits, which then require a huge effort to assemble, even though they're prefabricated.
That's right. I mean, this is one of the things that came out of all the other work we're doing together in terms of prefabrication, because one of the dilemmas is, there's always been an agenda to prefabricate rooms in totality and bring them and stack them up, which is one of the things that the construction industry has been trying to do quite a lot, and we looked into that for this particular building, but the mixed tenure is such that the space can't work like that. You couldn't have made it as a block and assembled the rooms in totality.
I think that's a broader point. I mean, when we're talking now about how we deliver, we want to try and speed up delivery, and we want to try and reduce the cost of delivery, and yet at the same time we want the quality. And as was mentioned earlier, really the greatest exponent of sustainability is this future flexibility, the ability to change the building, to change the mix, to change the composition of the uses. And so for us, we didn't want to go to some of those whole room volumetric solutions, because it ultimately restricts that future flexibility. And so here, we do have to find what is the right way of getting the most economic delivery, whilst at the same time taking advantage of the benefits of off-site manufacturing to deliver the quality and delivering that future flexibility. And I think that the panelised solution does offer that for us here.
So we got the benefits of prefabrication in there, also the benefits of in-situ construction, because the main frame is a very standard concrete frame. It's made on site, in situ. The difference was there, to speed up the construction, we used carpet reinforcement. Rather than assemble each bar at a time, you roll out the reinforcement, which is speeding up the whole process. So I think if you think of it as a whole, we probably got the right balance of advantages between prefabrication and in situ construction.
And I think there's another huge benefit of the concrete frame, which we shouldn't ignore, which is it does provide both a high degree of noise separation between the flats, which is clearly important in a multi-demise building, but also it provides a degree of thermal mass, so that the building does, when we look at the sustainable qualities of the building, we do have something which can absorb the heat load during the day and slowly dissipate that over the evening. And that huge benefit of concrete shouldn't be overlooked.
Fabrication becomes a mantra. We all agreed that the bathrooms, the kitchens and the facades, prefabricated, a lot of the rest of it can be done on site because it's simple. Factories aren't the solution to everything. It's the intensely skilled areas where you get the benefits of it. If you prefabricate a whole room, you're making a room in a factory and moving air all over the world. It's not necessarily the smartest thing to do.
Well, as they say, there's nothing faster than a concrete pour, is there? You can have them round tomorrow morning.
The MMC side of it, the modern methods of construction, was a big part of the London-wide initiative. It was the trend at the time. Everybody started, and even the English Partnerships was looking at a volumetric type of approach. But I think what we've been able to show, and I think we've moved away from that now, is that the flexibility in the type of building you can produce from volumetric has not proven to be that attractive. But what you need to do is creating good quality, this kind of prefabrication that can overcome those norms, without using miles and miles of mastic and various things like that. And I think this is what this is. There's some really good detailing on this scheme. And I think that's what's come out from all its inspections and what's proven to be so much of its success is it's been so well thought through, and there's not that kind of normal detailing that has suffered enormously on a lot of other buildings.
Hanif, can I just ask a question about, have other architect clients of yours said, oh, we'd like to do balconies like that, or are they too embarrassed to be obviously copying?
It's not just other architects, it's actually other clients as well coming, we want one of those. It's happening. I mean, it is worth saying that the simplicity of this is, at every level, is very deceiving, because the assumption then is that everything is simple. What I think we ought to be also mentioning is that when you do modern methods of construction and try to achieve simple things like this, there's a hell of a lot of power in computing that allows you to do this. So the current tools that we use in terms of the design and what a computer performs for us they're super complex, and that's what allows you to do simplicity in a much better way, in the way people see it. So more, putting my pure engineer's hat on, the reinforcement I was talking about, that was modeled on a very sophisticated program, so we could keep changing, and every time there was a cost change, we were told about it, we could measure it, go back and value it and change it as the production was going on. So there is a lot of deceit, let's say, in the simplicity of the project.
You've got a phrase to describe this, which is a lovely phrase, where you're either using complex systems to produce something very simple, or you reduce the complexity of something to a kind of in a simple way so that it can be understood.
Which we call simplexity, yeah, which we try to.
Thank you very much.